Hello, Assalamu alaikum, greetings, welcome to Learning Economics and welcome to our series Data Analysis using R. Dear viewers and listeners, in lecture 11, we learned many useful functions for working with strings. In this lecture, we come back to the strings and focus on the functions that use regular expressions. Regular expression is a concise and powerful language for describing the patterns within strings. So let's go on the RStudio screen and learn it. Okay, so first let us load the package tidyverse to the library. And this time I am going to use a different data set. So for that, I need to install the package named baby names. I need to write the command install.packages. We covered this command in our very initial lectures and put the name of this package within inverted commas, and sometime are asked for permission to restart the session before downloading. It is asking, and by clicking yes, I give it the permission to restart the session, and it is looking for this package, has loaded it, downloaded it, and stored. So let's load that package to the library as well. And let's view this package as well. Sorry, I need to reload the tidyverse to the library because this session has restarted. So everything that was loaded in the previous session have gone. So just let us reload that package. It has been reloaded. Now let's view this baby names. As you can see, it has total 5 columns: year, sex, that is male or female, name, number, and the proportion. The first topic that we are going to discuss today is detect matches. For this we use function str_detect, which returns to a logical vector that is true or false, and this is true if the pattern matches an element of the character vector, and false if it does not. What it means, let's see on the RStudio screen. So here on the RStudio screen, I use this str_detect function, and let me create a small vector A, which has character like A, B, and say C, and say, sorry, A, B, C. This is the vector, or this is the first argument where which is the target, where to look, and what to look is the second element. And here I want to detect if these elements are vowel or not. For the vowel, they must be either A or I or E or O or U. So I will give that criteria here, but I need to give it within square brackets. So I write A, E, I, O, U. And by writing it within the square bracket, I am telling R not to look for this as a whole, but to look for anything that matches with any of these. That is what I meant by the square bracket. So let's see. It says it is true, it is false, this is false, and since in this it has detected one of the letters which is A. So it has returned to true as well. Now, what happens if I do not give it within the square bracket? So now R will look for this as a whole among this first element or the target element and will return to true if it is really there and false if it is not there. So AEIOU as a whole is not here, not here, not here, as well as not here. So everything is false. And since str underscore detect function returns a logical vector of the same length as of initial vector, so it pairs very well with the filter function. For example, if we need to find all of those baby names that contain, let's say, X, what we shall do, we shall use this as baby names. And using this pipe function, I will ask it to filter using str underscore detect. And here the first element will be the target where it should look. The second element is what it should look. But I'm not just stopping here. I am giving it another thing to perform as well. So I ask it to use this information as an input for the next, where I am asking it to count the name with respect to n and sort them as well. And by sorting, uh, it will place at number 1 the name which is most repeated, and then on the number 2 which is the second most repeated and the third most repeated according to the given criteria. So let's see. So here it has filtered all those names that contain X and it has returned to 974 rows instead of these many entries. And here it has also arranged them in in descending order. So this is how we can use str underscore detect for our data analysis. However, there is another function that is str count, which returns to the counting number of the matches. That is, rather than returning to the true or false, it tells us how many matches are there in each string according to the criteria given. Again, here the first element will be the target area and the second element will be the criteria or what it should look for. So let's come back to the RStudio screen, which is, for example, apple, okay, banana, okay, and say oranges, and okay, and say dates. And oh, sorry, I need to write this C for the column over here. Okay, it has created. Now I use str underscore count and I say your target is X and count me A's. So in the first there is 1A, in the second there are 3 A's, in the third there is 1A, and in the fourth there is 1A. And if I say it to count, for example, B, so it returns 0 B's, 1 B, 0 B, and 0 B. Please note that each match starts at the end of the previous match and it never overlaps. For example, if I use this str underscore count and my first entry is A, B, A, B, A, B, A. So this is the target area and I ask it to, for example, look for ABA. It returns to 2, not 3, because it finds ABA, it counts 1, and then it starts matching after it. So after it, it starts from the B, it doesn't match. Here is the other match, ABA, it counts 2. It doesn't count it in overlapping way. If it had counted in the overlapping way, it would have counted as ABA, then ABA, second match, then ABA, the third match. It has not done like that. Now, let me use this string to show you another interesting thing. And for this, I'm just copying and pasting the code to save the time, but let me explain the code to you. We are using the baby names and asking it to pass this information to the next function, which is count names. We are asking it to count the names, how many times the specific names are repeating, and then pass this information to next function, which is mutate. Mutate actually creates new variable, and here we are creating one variable which is vowels, and here we are asking it to count among the names this A, I, O, U, and within square bracket it means any of this. And second variable consonants, which is anything not vowels. So we have written vowels over here and have added this symbol. So anything but not among these. And let's see the results. It says that this name AABAN appeared 10 times. Let's check it. I am going to the filter on the names. I am writing this AABAN, and it has returned to these 10 entries. So yes, it has appeared 10 times. It contains 2 vowels and 3 consonants. Why? It has this capital A, this small a, 2, and this small a, 3. Why 2? Just think about it. 3, 2, and 1. Let me tell you why. There is nothing wrong. Actually, we have asked it to see this, and you know that R is case sensitive. So anything in this case and matching with these elements will be considered as vowel, and anything which doesn't match with this, either as a character or as of its being capital or small, that will be counted as consonant. So it has treated this A as consonant, this P as consonant, and this N as consonant. So there are 3 consonants, but this A and this A are vowels. So 2 vowels. And similarly, we can see this A first vowel, second vowel, third vowel, this E, and fourth vowel is this A. And consonant, this capital A, this P, 2, these are 3, and these double L, 4 and 5. So 5 consonants. But how we can deal with such problem? We know that even capital A is also a vowel and small a is also a vowel. So how to deal with this? There are 3 ways to deal with such problems. First is we need to rewrite this code, and vector, we have given this in smaller, we should give the same letters A, E, I, O, U in capital as well. And here too, A, E, I, O, O, U. Now it says that there are three vowels this time, this capital A, this small a, and this small a. And there are two consonants, this B and this N. So it has resolved this problem. The second way to deal with this problem is to ask R to ignore the case. How we can ask the R to ignore the case? So we come to this code and here we write regx, which is something for regular expressions. I first give this expression. I'm copying and pasting it over here. And then after this, I say ignore underscore case is equal to true. And I do the same over here. So I write, I am just copying it from here. I am pasting it here and just adding this symbol. And so here again, it has ignored the case. So anything small or capital has been ignored. So this is these two and this one, three vowels, and rest are consonant. The third way is to convert it to the lower string first and then use this function. How to do this? Let's go to the original function first. Okay, and here instead of this name, I call another function which I say str underscore to underscore lower, and here I give the name of that column which should be converted to lower string. And I do the same over here. I write str underscore to underscore lower, and within bracket, I give the name of the column, and rest is the same. So let's see it. And again, it has worked well. So these are the three ways to handle this problem of lowercase or uppercase. If you are working with any data set that contains many names, you often might come across such a problem, and that's why we have spent quite a good deal of the time on how to tackle this problem. Now, in the last part of this lecture, we see how we can replace some value within a string. And for this purpose, we use the function str underscore replace and str underscore replace underscore all. Str underscore replace basically replaces the first batch, and as the name suggests, str underscore replace underscore all replaces all the matches. As we have already created a vector of x, so let's do this on this character. So I use str underscore replace underscore all, and I give it the target as x. And what to be replaced? I write A, E, I, O, U. And by writing it within square bracket, I mean any of these and what it should be replaced with. Let's say I say it dash. Okay. So just I need to put inverted commas over here. So let's see. So APPLE, A and E are replaced. BA, NA, and A. So all the A's are replaced. ORANGE, OAE, dates, DATE. So all these are replaced. And similarly, I can use remove all function as well. So if I use str underscore remove underscore all, the first is the target and second is what should be removed. So all these vowels have been removed. A removed, PPL retained, E removed, and same goes on. So before end of this lecture, let me tell you something important that you can connect with today's lecture as well. A few years back, I read a very good paper and there was a very good work, but the work was on the names and it used Pakistani names dataset and used it to see the impact of some of the tax policies. And as you might knew that in Pakistan, the word Muhammad is the part of many names. So like I have the name Muhammad Nareem Sarwar and there are many people you will find whose names start or ends or contain somewhere Muhammad. And people spell Muhammad as Muhammad as well as Mohammad and sometimes do write as I write like just M. So with all these, the name is same. So what they needed to do is to make this similar across the whole data set. And a few years before when I was reading this paper, I was amazed that there are thousands of the names in this data set and how much work this man would have done just to convert those names. And now, today, as I'm teaching you, I can recall that it was not some big work. It was just a command of R through this. It could have modified it, could have replaced all those O's in Muhammad with A, or all those M dot anything with complete Muhammad or whatever spelling he or she would have liked, and that would have happened in just 2 or 3 minutes. That's actually something I could recall today, and it's really interesting. So, learning new things, learning good skills definitely increases your productivity. And if you want to increase the productivity of your fellows and friends as well, do share these lectures with them. With this, thank you, take care, and bye bye.